Good morning to everyone. Myself, Shah Hamid. In this video, we are going to start a new chapter, testing. Testing is one of the fundamental parts of software engineering. Let us see testing in detail. What is testing? Testing is a word which you people have been very familiar with. In the past 2 decades of your life, you all would have written numerous tests. The goal of the test or exam in the school is to quantitatively assess how well you have understood the concepts. Likewise, software need to be tested to check how well it performs, just like your exams, which test your concepts. That is, does the software really do what it is supposed to do? Correctness, validation, verification are some of the terms related to testing. They are more or less one and the same. All of them are quite interrelated. Next, let me give you several points which will motivate you on why you should study software testing and how important it is for the country and for your personal good. Software testing is. As I used to say in the initial classes, most of you would most probably will be getting placed in IT jobs only. And the only subject you might probably end up actually using in your IT career will be software engineering. If you see this slide, I have mentioned that 75% of CS degree holders might end up with IT jobs. This number can be more actually. And in fact, even in other departments like civil, chemistry, most of the placements are still in the field of IT only. As per this slide, the two main broad types of software engineers role are software developer and software tester. Okay, this is a very broad classification. There are other software roles such as security engineer, network engineer, software architect, and etc. But these roles are very less in number. Developer and tester are the two major roles. Most of the freshers prefer to get the developer role, as developer role naturally involves writing new and interesting code. This is quite respected. But still there is a good chance to land in a tester role as well as a fresher. Okay. The interesting fact here is, even though let's say that you get a developer role, still half of the time you will be very closely working with the testing team. Each and every piece of code will be sent to testing. Each and every piece of code that you write as a developer will be sent to testing. Okay, so you are supposed to be familiar with testing, and testing will be a part of your life if you are in IT job. The process of development and testing are tightly coupled. They happen in a continuous feedback. One is followed by the other and it repeats in the process of development and testing. So in essence, testing will be something that will be a part of your life if you join the IT industry. This alone should be a strong enough motivation to study and understand testing. Okay, so I hope you will understand how important this chapter is. Let me give you one more perspective to motivate you regarding why testing is important. In NPTEL, I know you people will be familiar with NPTEL. In NPTEL, you can find several courses on software engineering, which is quite common. And if you search it properly, there is one complete dedicated NPTEL course just for testing. Okay, you have a dedicated NPTEL course just for testing alone. In fact, some of the contents for these video classes have been taken from that course only. The fact that NPTEL has a dedicated course just for software testing should show you how important testing is. Okay, you people are studying testing as a chapter, whereas in other colleges, testing itself is studied as a subject. Software testing is studied as a complete subject. People in IT industry do certificate courses on testing for career advancements. Okay, certificate courses. So hereby I hope you that I have satisfied you people regarding how important testing will be in your career, and I hope you all would take this chapter very seriously. Okay, in this slide, let us see some more practical reasons which makes testing a very important aspect of software engineering. First, software is omnipresent. Every object you interact with in your daily life will have some form of software working on it, executing on it, either directly or indirectly. be it phone, computers, washing machines, cars, aeroplanes, and many more things. They run on software only. If software is so common, then it is actually quite necessary for it to be functioning correctly. A failure or an error in a software could have consequences ranging from minor nuisance to catastrophic failure. If your calculator performs a calculation wrongly, that is okay. You can buy another calculator. But imagine autopilot software running on an aeroplane, autopilot software malfunctioning midway during a flight. Here, this particular software malfunction might result in a crash of the airplane. Okay, since software has a broad application, it is necessary to test them properly so that such errors, be it minor errors which can be a nuisance, or such catastrophic errors like failure in autopilot software, things like that, we should make sure that such consequences should not happen very often. Okay. Now let us see some popular software bugs or errors which resulted in huge economical loss. Sadly, in some cases, human lives were even also lost simply due to software errors. I hope you people understand the intensity. Due to software errors, human lives have been lost. Okay. Ariane 5 is a space rocket which crashed immediately after takeoff due to a software bug. The error was the system tried to store a 64-bit integer into a 16-bit register. Okay, just because of this seemingly small error, the system miscalculated certain critical values and the rocket ultimately crashed just immediately after the takeoff. Imagine the amount of loss an entire nation had to face because of a register overflow error. The next case is Intel Pentium bug. Intel Pentium bug is another interesting error. This is interesting because this is a hardware error. Okay, error and bugs need not be only associated with softwares. Sometimes, quite rarely actually, errors may also occur in the hardware also, typically in the embedded systems. This particular Pentium processor performed division wrongly for numbers in certain range. Okay, due to this, this happened due to a malfunctioning circuit design. Due to this, Intel has to retract thousands of processors already sold out into the market. Thus, it is important to have a good testing protocol when designing embedded systems also, hardwares also. Okay, the third event is Amazon double discount error. This happened in the early 2000s, where the Amazon website mistakenly gave double the discount for each of the product. Okay, and as a result, Amazon incurred a huge loss. Likewise, there are several other popular software errors which had caused catastrophic damages. You can Google them out. These incidents in the history shows us that how software errors can cost us if we are not careful with them. There are some organizations which releases yearly report on how much a country has lost economically due to software errors. Okay, it seems that these numbers keep on increasing year by year, which should not happen actually. Now let us see what is the cost the company has to incur in order to deal with bugs and errors. Okay, the errors can be found at each stage of the software development cycle. It need not be found only at the testing stage. It can be found at any stage, from the very initial requirement analysis to any stage. Okay, be it requirement analysis phase, design phase, or coding phase, or coding phase, be it any such phase, there is scope for an error or bug to happen in each of these stages. So it is important to test the deliverable at each of these stages. Okay, you should test then and there so that any mistakes in a given stage can be corrected then and there itself. Error ignored in the requirement phase, the first phase, and let's say that if it is found on the same error is found out in the coding phase, it will be very difficult to address that error. Okay, you have to change everything in between because the error was ignored at the initial state. So it is necessary to rigorously do testing at each stage of the software development lifecycle, at each particular stage. The later the error you find, the more difficult and costly it would be to correct it. In this context, in recent times, there is a heavy shift in the approach towards testing, software testing. Okay, nowadays in the IT industry, software developers are themselves encouraged to do unit testing. Okay, we will be studying in detail about what is unit testing. Okay, unit testing is nothing but the code written by the developer should be tested then and there by the developer itself. Okay, instead of sending it to the testing team, as of now, the industry is moving to a trend where the developer himself or herself is expected to test the code. Okay, this would make sure that most of the bugs are figured out at a very earlier stage. Thus, the major change here is the gap between software development and testing is reducing day by day, and developers are encouraged themselves to test the code they write. Now, let us see some of the popular facts and myths about testing. These points should hopefully help you to give a realistic perspective of what is software testing actually. Okay, let us see the first point. Testing can be used to find errors in software. Testing alone cannot be used to show that a software is correct. Here, I would like to talk about the relation between theorem proving and testing. Theorem proving. Okay. If you think about it, both theorem proving and testing are very similar. In theorem proving, we prove that the statement or the theorem hold always. If you recall your discrete mathematics course, you will remember that to disprove a statement or a theorem, it is enough to give a counter example. To disprove a statement, a counter example will do. But to prove a statement, you are supposed to give a logical proof. The logical proof is a generalized set of statements which logically proves that the theorem or the statement holds true always. Proof is a generalized statement which claims that the theorem holds true for all possible inputs. For example, the proof of Pythagoras theorem says that Pythagoras theorem holds for any right triangle possible. The Pythagoras theorem holds for any right triangle possible in the entire world. Okay. Note that we don't take each and every right angle triangle possible and check whether the Pythagoras theorem holds or not. Okay, you are not verifying it for each and every right angle triangle that is possible, because there are infinite number of right angle triangle. You can't just go and verify it for each and every right angle triangle possible. Okay, rather we come up with a proof which logically proves that the Pythagoras theorem will indeed hold for any right angle triangle, any possible right angle triangle. Okay, this finite set of statements, that is the proof, proves that this Pythagoras theorem holds for any right angle triangle. Okay, so that is the proof. But on the other hand, to disprove something, to prove something is wrong, it is just enough if you show a counter example. Okay, a single counter example is enough to disprove a statement. Okay. Now let us talk about software testing. Okay, in this context, the relationship between theorem proving and software testing. Okay, in this situation, to essentially claim that a software is correct, you are supposed to prove it. Okay, ultimately, you are supposed to prove. You say to the customer that the software you made is actually correct. Okay, but as per the mathematical approach, to claim that something is correct, you are actually supposed to prove it. Okay, but do you think that happens? It doesn't happen in the case of software engineering. Okay, correctness requires proof. In fact, there are formal approaches to testing the software where people actually try to formally prove that a given software is correct. Okay, formally in the mathematical sense. This is actually an active research area. You can Google it out. Okay, if you are interested. But as you can see, software is not simple like a theorem. Okay, a Pythagoras theorem is very simple, whereas software can be 1,000 to lakhs of lines of code. Okay, so software is not simple. Okay, software is complex. Software is quite complex. Thus, what we are trying to do is, instead of trying to prove that software is correct, we try to come up with counter examples to show that the software is incorrect. Okay, the testing actually tries to find bugs and errors. The bugs and errors are actually nothing but they are counter example. They shows that in this part the software is failing. Okay, and that part is supposed to be corrected. These counter examples are nothing but errors or bugs. Okay, by identifying bugs and errors, we try to reduce incorrectness. Okay, we are trying to reduce the incorrectness. We are in no way we are proving that a software is correct. Rather, the mistakes or incorrectness are being weeded out. They are being removed by testing. Thus, the implication here is, however many errors you find and correct, there is no assurance that the software is correct. Okay, you are not proved anything. You are just removed or weeded out the possible errors which you have come up with. Okay, there might be one hideous bug or error hiding which you may never find during testing, but it may turn up at a very later point of time. So to conclude, testing is essentially used to find errors in software. Testing alone cannot be used to show that a software is correct. Okay, I hope I am clear with this point. Now, the next fact. Testing cannot be replaced by software reviews, inspections and other similar processes. Reviewing the software, inspecting the code are also very critical to develop a good software. Okay, so they are very important. Testing alone cannot replace all these things. They are also an essential part. Next fact. You would have heard about many automated testing software suites. Selenium is one such popular tool which automates testing. But note that you still need humans to operate Selenium. Okay, though Selenium is a tool to automate testing, Selenium need to be programmed by humans only, which means that human intelligence is essential for testing, and hence testing cannot be completely automated. Okay, you need human intervention. The last one is a myth, and I feel that you all can relate to it. You all would have felt that you have written a correct code, maybe in your lab. It would even compile successfully, but while running there might be some logical error. Okay, so thus this is a myth. In this slide, you can see the various objectives of software testing. By the end of this chapter, you are expected to know something about each of these 4 bullet points. I leave it to you to read it. Thank you. Let's meet in the next class.